Good evening. We are in the first live session of this course. Hope you all are enjoying learning this course, the contents. We are here for addressing whatever doubts you have. Feel free to write your questions, doubts in the chat box, and we will take them one by one. So, whatever doubts you have, please post in the chat box. In the meantime, till some of you post the questions, doubts, I would like to mention one correction in the lecture 28, question 3, which was a solved problem in the tutorial. It was mentioned 4.05 into 10 to the power minus 4 electrons are required for electrolysis reaction. There you read it as kilomole. 4.05 10 to the power minus 4 kilomole of electrons I have required for electrolysis reaction. So please note this change. Yeah, good evening. Please write your questions in the chat box. There is one question in the discussion forum. Until I could see other questions in the chat box, I will take that up. What are the factors which influence the efficiency, lifespan of electrolyzer? So if it is direct relationships like efficiency, we can, the formula for it. Whatever factors are included in that efficiency expression, they definitely influence. Other than that, which are the practical, in a practical scenario, quality of water is a very important characteristic. Then there are membrane related properties. So if it is an open cathode, self-humidifying, or if there is a humidity lack in the membrane, then that may also affect the membrane. So whatever are the impacts onto the membrane or catalyst, if your catalyst also get impacted, in that case, the lifespan of the electrolyzer reduces. Besides transient, although PEM electrolyzer, so we have also discussed the different technologies of electrolyzers. And based on that, their susceptibility to transients vary. However, PEM electrolyzer, it can see large variation in the load, a large variation in the current, so your voltage, but the other electrolyzers, these fluctuations of the transients can impact. So there are multiple factors which can affect the life of an electrolyzer. Yeah, those who have doubts about any of the previous lectures, please feel free to write that in the chat box. So there are no questions, seems everything is very clear. Shikhar has asked a question, how we can use hydrogen as a fuel in India, as we are using methane as fuel in automotive, domestic, industrial sectors, as safety risks with hydrogen are very high. To this question, I will, because we don't have many questions there in the chat box, so I will elaborate onto this question. If you say industrial sectors, as we have also discussed in the course, that hydrogen is being used in industrial sector for quite some time, several decades. It is used for ammonia synthesis. It is used for fertilizer industry, for various refinery operations. It has been used, and they have used it safely without any incident when the safety protocols are being followed. So it is not that it is a new fuel which is going to replace in the industrial segment. It is expansion in the industries, wherein earlier we were using for limited industrial application. With the widespread used, it will be used in various other processes and chemical processes and other industries. Like there are prototypes which are being demonstrated in steel sector, so cement industry. Also, there are testing going on for domestic use for combustion, heating. There are several demonstrations going on globally. And hydrogen as a fuel, definitely you all know that there are several demonstrations. There are different companies which have come up their automobiles with fuel cell powered hydrogen fuel cell powered vehicles, cars. Even our honorable minister has been using the fuel cell powered car. So it is like methane, it has all those applications possible, whether it is automotive, whether it is domestic, whether it is industrial sector, we can use safely. Important is towards the end of this course, we will talk about hydrogen safety. So there are standards existing, there are safety protocols existing in place, which you need to guidelines, which you need to follow in order to have safe usage of hydrogen in the various sectors which you are asking for. So it is not a problem, it can be used. The difference is when one point of time when we started using CNG in these sectors, that time once it is a new fuel, definitely there is an anxiety. Provided its expansion, its usage increases widely, those anxiety issues or the public acceptance will increase with time. But yeah, definitely there are characteristics of hydrogen which are very much different from methane, and that makes it as a special fuel. Definitely advantages are there, but then at the same time there are risks. But these risks are, so there are already standards, protocols existing. If you follow that, it is a safe fuel to use. Yes, I will take, I hope I have answered your question, Shikhar.
So there's a follow-up question by Shikhar. How can we use hydrogen as a blending fuel with methane?
There is possibility, yes, definitely. It can be used with methane blended. If you see in news, yeah, Professor Sandeep Kumar has joined.
Hello everyone. Sorry for the delay.
So I was talking about the blending of hydrogen with methane. So there have been several demonstrations in our country itself. IOCL has run several buses in India, and this has run through Delhi Sonipat route, and they have demonstrated, and also they have ran, I think, more than 100,000 kilometers already. So there it can be used definitely with blended hydrogen. The question mark was how much percentage of hydrogen blending should be allowed in the current condition, in the current scenario. So that is what was the question mark, that also being identified, this without any embrittlement or other changes required in the infrastructure. So safe percentage was the question mark. Rest it is blended and being used and demonstrated.
So we have another question from one of the students. Here he's asking, how efficient is hydrogen as compared to fossil fuels and electricity?
Yeah, so when we talk about the efficiency, it depends on the process. So if we are looking into hydrogen, there are two major uses that we are looking for. One is the fertilizer production through ammonia. So when we look into that, so there is no question of efficiency, but it's the availability of hydrogen. So that methane has 4 atoms of hydrogen into it, but also carbon. So that is coming out as a carbon emission, CO2. When we look into hydrogen coming from water through electrolysis or any other source, it will be carbon neutral. So there the carbon intensity is getting counted, and there these are green fuel, zero carbon, or the carbon negative or carbon neutral fuel. When we talk about the other uses, say steel, the direct reduction of steel, there also it is getting used as a reducing agent, which earlier, currently it is coal is being used, which is releasing CO2 as a byproduct. reducing iron from iron ore. So that way again, hydrogen coming from a green hydrogen source will be zero carbon emission. Efficiency is not a major question here. The cost is something which people are looking into, how it will be cost and reliability compared to the knowledge or the process of coal use in steel industry that we are using for centuries. So third thing comes as a fuel in the vehicles or in the burners or in the, say, cooking systems, thermal systems. There, the efficiency of the combustion of hydrogen is actually better than the conventional fossil fuels. If you just Google about the one of the vehicle BMW has developed way back in 2007. So it's hydrogen run car, and that actually has much more thermodynamic efficiency compared to the diesel engines. The same thing goes with the burners. So the hydrogen-based burners, or even when we are talking about adding 5% hydrogen into piped natural gas, there the combustion efficiency of hydrogen is 5 to 10% more compared to the LPG or the natural gas. So there we can say the comparison about the energy efficiency in these systems, it is much better. Now, when we talk about use of hydrogen for power production or electricity production through using fuel cell, there it has almost twice the efficiency compared to the conventional IC engines. If you use any conventional fuel, whether you are using natural gas for using gas turbines for power production or diesel for using IC engines for power production, compared to that, or vehicle movement, we are using IC engines. They are thermodynamic cycle based. They have less efficiency, 25 to 35% at max. When we compare fuel cell based vehicles or fuel cell based power generation, that we can easily achieve 60 to 70% efficiency. There it gives almost twice the efficiency compared to the conventional engine based systems.
So we have another question from Shikhar. He's asking, are other countries using hydrogen as fuel?
Yes, there are. So several countries, they have come up with, in fact, many of the countries have been pioneer in taking steps towards hydrogen utilization. They have come up with their roadmaps, prototypes, demonstrations in various sectors. And many of the globally, the governments, they are taking steps towards it, adding the hydrogen as a fuel into their energy systems. So definitely most of the countries, I will say, they have started their initiatives way ahead, and they have their mission documents, targets, and all well documented strategies, roadmaps in place. All those we will see towards the end of this course. What is the global scenario?
So as a follow-up, Shikhar is mentioning a concern. He's saying, but energy per SCM is lower than methane. How can we address this?
Yeah, so actually this is about the volumetric energy density. So it is not one of our major concerns when we are talking about the efficiency and all. It is only about the utilization. So when we say if we are using it as a fuel for vehicles, then yes, your tank which will store hydrogen, whether it is a compressed tank or a metal hydride tank, will be carrying less energy and you will get a less mileage. But when we talk about other applications like say ammonia production or steel sort of a reduction, there or power generation, where space or volume is not a constraint, it is not actually a major problem. So, but yeah, when we talk about say methane, we are using CNG or the compressed natural gas. In a 60-liter tanks, it has the energy which is not more than 12 or 13 liters of petrol. So, but still, we are seeing that people are using it currently. The CNG-based vehicle sale has almost touched more than 25%. So means people are using it even though it has less energy density. So, but that is not one of a major concern which applies to many sectors except vehicular movement. It's not a major issue in other sectors.
Another query that we have is that can hydrogen be used for flying aeroplanes?
So there it's a sort of a concern that aeroplanes requires a fuel which should have a very high energy density. Otherwise, what will happen? You will end up occupying a lot of volume, and for the tank or the storage systems of that will become quite bulky or heavy, and that weight will not be of hydrogen but the fuel tank. But if you look into other areas like say cryogenic engine being used for space application, it is actually a liquid hydrogen which is propelling your sort of a biggest space missions. Even the GSLV missions, they are using cryogenic engines using hydrogen as a fuel, and similar is for the major space exploration. So hydrogen is not a bad fuel for that, but yeah, when we look into commercial aviation sector, then somebody will definitely look for having a fuel tank which can go for 5 to 10,000 kilometers in a single stretch without refueling. Their hydrogen has to, or systems has to work still a lot. And we will see that there would be technology solutions in future for that. Yeah, sure. We are also hopeful that soon we will see the hydrogen economy being a major player in overall energy scenarios. So hopefully.
You can keep posting your questions, doubts in the chat box. Discussion forum questions to be taken.
So anyone has any further queries or questions?
We have another question. Production of hydrogen cost energy. So it's not intuitive for me. How can it be economical in the long run?
So if you see hydrogen production from steam methane reforming or from fossil fuel, it is at present also competitive. But if you see green hydrogen, then definitely the cost as of now is way higher. But then economies of scale it is expected that economies of scale will bring it down. Other aspect is when you compare it with long-term large-scale storage, then this could be a very important carrier which could be which could store in the form of chemical energy for long term. So at present, if you are talking about green hydrogen, yes, it is not cost competitive. But if you see the cost of fuel cell in few years, in fact, has come down drastically. And it is expected that with the technology, with the better materials, suitable materials, which could replace the expensive materials, the platinum group metals, the cost could go down. So it may take some time. Let's see how it evolves.
Just to give you one perspective from the historical side, natural gas, which you see one of the cheapest fuel available across the world, was not so 50 years, 60 years back. So the companies, researchers put a lot of effort in developing a low-cost transportation system that evolved through liquefaction. So now the LNG, liquefied natural gas, is being used for transporting this natural gas in a high energy dense manner to the ships across the globe. We have the pipelines to supply the natural gas. And now you see, but if you ask somebody 60, 70 years back, they would say it's a gaseous fuel. It doesn't make sense to explore in Russia and transport it to Europe or India or so. So, but right now that is one of the cheapest fuel available even from thousands of kilometers of transportation. So we expect that hydrogen system will also get such breakthrough in near future where it will make sense and make it very, very competitive with the existing fossil fuels.
Another question that we have is that we are deriving hydrogen from methane by steam reforming, but is it economical in MMBTU terms to derive less energy from higher calorific value fuel?
Yeah, so actually it is not, definitely not. So you are having methane as a fuel and getting hydrogen as a final product. And definitely when you do any processing, none of it will be 100% efficient. Definitely there will be losses. You are supplying energy and all in processing it to get hydrogen. But the thing is, hydrogen is derived from steam, or sorry, methane, not for fuel. In a large sort of a scale application, it is used for fertilizer production. It is used as a chemical for processing in the chemical industries. It is used for hydrogen as a chemical for processing petroleum, or what we call the fracking. So those are used as a hydrogen as a sort of a chemical for that. They are not used as a fuel. But yeah, if you are converting methane to hydrogen and then trying to add that hydrogen into CNG tank 10% or 20% and running the vehicle, then it doesn't make sense. Definitely. But yeah, there the green hydrogen should come into picture. But methane is majorly used for hydrogen for chemical applications only.
So if you have any other doubts or question, please post in the chat box. At present, there seems to be no questions. So we'll wait for a couple of more minutes.
We have another question. Can hydrogen be captured during crude oil mining?
So when we talk about the crude oil mining, hydrogen, so there are a lot of work going on in getting the hydrogen from the earth crust itself. There are some sort of a sign that hydrogen could be present there in the earth crust in some other forms. So, but yeah, right now it is still in the research work. And when you say crude oil, conventional crude oil currently, which we are using for petroleum, so there it is not feasible right now. So, but yeah, we are trying to, lot of work is going on to identify those areas where we can capture or get the hydrogen directly at a reasonable cost or affordable cost from the earth crust.
So there, the economics matters, that the amount of hydrogen which you have captured against the amount which you have spent in developing that infrastructure. So whether it is viable option or not, that is being considered, and then a lot of research is going on in that area.
We have a follow-up question. At last, I want to ask, what will be the pattern of exam?
It will be MCQ based, and whatever covered in the course will be asked. Okay, so you can even post your questions, doubts in the discussion forum, and we will respond there as well. If you have no further doubts, we will close this session. Or if anyone have any doubt question, can post in chat box now also. But yeah, later on also, if something comes to your mind and you have any doubt in any part of the lectures, you can post in the discussion forum. So as of now, we cannot see any other further questions, so we will close this session.
There's another point.
So,
Please post the slide chat discussion.
It will be there. It will be available. Okay, thank you.
Thank you, everyone.